Yeah, the party last night was awesome, so thanks to Google for that. They had Gwen Stefani there, and I realized as I was at the party that Gwen Stefani is probably a tech worker. And I'm convinced of this because her last song, Holla Back Girl, I'm convinced that that song is about being on call, because she ain't no holla back girl, so she doesn't want to be on call. And she says, this shit is bananas, B-A-N-A-N-A-S. And I think that explains pretty much all of our systems that we build, which is why I want to talk about chaos. Things are bananas. Oftentimes when I'm building stuff, my reaction is either, oh my God, that worked, right? Because it's just like, I can't believe this stuff actually works. Or it's like, oh my God, that worked? Like, you have a problem, a system goes down, and you're like, how the hell did this work in the first place? Like, this shouldn't even be functioning. So chaos is about learning about our systems. So more fun quotes. I love this quote from Barack Obama that says, you can't let your failures define you. You have to learn, you have to let your failures teach you. You have to learn from them. Which is what chaos is really about, right? Our systems break all the time. There's a researcher on safety named David Woods. He gets mentioned in a lot of DevOps sort of circles. And he has this quote that our systems are in a constant state of failure. Like, failure isn't binary, it's just a spectrum. And so if we understand that we're failing, and that's okay, right? Because we can learn from it. Now, Barack Obama talked about a whole lot of things. He talked a lot about hope. Unfortunately, that's maybe not a good thing. So I love this quote about hope. Corey Bertram's the VP of Infrastructure and SRE at Datadog. And he likes to say this, that hope is not a strategy. Right? We can't hope that our systems will stay up. We can't hope that our software will deploy without any bugs. Right? How many people deployed sometime this week? Deployed some code, deployed infrastructure, spun something up? That's most of us. How many people deployed bad code? You had a bug, or you deployed infrastructure and it broke, and it's pretty much the same amount of hands. If you didn't, then I don't know. Good job on you, or maybe you missed something and you should be really worried. So the other thing about Corey, though, and the reason that Corey says this is Corey came from Netflix. So he was part of the team that started implementing a lot of chaos around things. And so the backstory of this is that Netflix was moving from on-prem to the cloud. And as they were doing so, they realized a lot of things about the cloud, right? They realized that the cloud isn't about resiliency. Even though Google provides us great SLAs and they're up most of the time, just like us, there are issues, and they work to resolve them. But the great thing about Google Cloud is that you can spin up new resources all the time, right? So you have this ability to constantly have more resources, and that means that rather than avoiding failure, you can embrace failure. You can start planning for failure and doing things like rollovers or auto-scaling and things like that. So they had a lot of these lessons, and the number one lesson that I like from this blog post that they posted was that the best way to avoid failure is to constantly fail, right? To constantly try to fail, do those painful things, and then learn from them. And this led them to creating a thing called Chaos Monkey. Who here has heard of Chaos Monkey? Yeah, I think we all have at this point. Who here has heard that it's this program that randomly deletes your servers, takes things down? Yeah, I mean, that was the point, right? Unfortunately, I think a lot of us have believed this, and if you go back and read the blog post, it's sort of a myth, and I'll dive into that in a bit. So who am I? I don't come from Netflix. I'm Jason. I work at Datadog. I'm a technical evangelist, which is a really fun job. It means I get to come and talk to people like you. I get to help our customers. I get to learn stuff and then teach people as well. Bunch of things about me. I do actually have a hat like that. I play a lot of Pokemon Go. If you see me wandering around later, I'm not lost. A little bit about Datadog. Datadog is a SaaS-based monitoring platform. So we work with Google, we work with your on-prem. If you're doing multi-cloud, we work with all the major cloud providers. But we ingest all of your metrics, your traces, distributed traces. We collect your logs, help you do log analytics, and we launched a new synthetics product. So essentially, we try to get you all the observability tools to let you know what's going on in your systems, let you know where you can find those issues when something does happen. And this is important when it comes to chaos. So back to Netflix and talking about chaos, right? If you actually go back to their blog post, it says this, that by running Chaos Monkey, not randomly, not at any given time, but in the middle of a business day, in a carefully monitored environment, with engineers standing by, well, then we can address those problems and learn the lessons that we need to learn about the weaknesses in our systems, about how to build automatic recovery mechanisms, which is one thing, as mentioned, that the cloud enables us to do. And so by doing all of this, then maybe at 3 a.m. on a Sunday, on those random times, then we won't even notice, right? We can build all these things. So lesson 1 from this talk, if you come out of here and you're like, yeah, I'm going to go do some chaos stuff, and you're doing it in the middle of the night, and you're not telling your colleagues, and you're waking them up in the middle of the night, then you're a jerk. And my number 1 lesson is don't be a jerk, right? We'll talk about how to plan these. We'll talk about how to run these so that you're actually learning and being a good colleague. So at Datadog, we start with game days. And the main difference between game days and chaos is that game days are very much a manual process, and that's where you want to start, right? You don't want to just jump into automation that you don't understand. So just like any game at Datadog, there are rules, right? I was in Italy, so this is the Italian soccer team, and I was pointing out to them that the rules are there to make the game fun, right? If you were playing a soccer game and there were no rules, well, then I can come up and punch you in the face and take the ball and run through it in the goal, and you'd be like, hey, that's not soccer, that sounds like rugby, right? It's only fun if there are rules that we all agree upon. And so the rules make things a little less scary. They let us know what to expect. So the rules of the game day are just like a soccer match. It lasts 90 minutes, right? We want to time box this. We don't want it to go on for a full day because then we lose productivity. We don't want things to just drag on, so we keep things nice and short. Within that 90 minutes, we spend 30 minutes for planning. Again, we want to keep this short. Nobody wants to spend half a day or a day planning what they're going to do. So 30 minutes, nice short period, doesn't take too long. Then we spend 50 minutes playing. This is the actual fun part. This is where we get to test our systems. This is where we get to break things and see what happens. And then again, 10 minutes at the end just for reporting. And we don't want this to be too long. Again, if it's too long for reporting, nobody wants to do it, right? That's the boring part of things. So the 10 minutes, nice and short. And I'll dive into how this works in a bit. But let's talk about the team. Every game has teams. So our teams are nice and small. We don't want to take up everybody's time because, again, we lose productivity. So the team ends up being usually two people. The first is a subject matter expert, and that's going to be the developer who built the service, who knows the most about it. It might be the ops engineer who architected this particular service's infrastructure. Whoever knows the most about it, that's the person that's going to be the main player on this team. The next person is going to be someone from the SRE team. So they're going to partner up because the SREs are really those experts on how to keep your systems running, how to keep them reliable, what the best practices are. Right? So now we can partner up with the person who's building things, the person who essentially helps ensure that they stay running. It's a good team. Sometimes, though, we add a third player. And that third player is going to be a junior engineer or a junior developer. And more often than not, I like when we have a third player because that third player, this junior engineer, is the person that knows just a little bit about that service or just a little about that infrastructure. So when you take something down and you see some weird symptoms around that, this is the person that has no idea why that happened. They're the person that asks those questions because there are no stupid questions, but they ask those questions about why did that happen, right? What's going on? Wait, why did we do that in the code? Why did we build that this way? And for most of us that have been around, well, you're like, well, of course oh yeah, that's not really the logical way. We did it because there was this other constraint. So that's the great thing about it. The other nice thing is, as a more senior engineer or developer, you get to mentor that person, right? Now they're seeing the reasons that you built that service or that system in a particular way. They understand now when you say, oh yeah, I did that weird thing because this constraint, Now, as a junior engineer, when they come up with strange constraints or things that they're not familiar with, now they have some reference of like, oh, here's a creative way that you did it. So let's talk about those times, though. 30 minutes spent planning. What do we do for that 30 minutes? Well, number one, we have to schedule this, right? We want to ensure that we have enough time to do this 90 minutes. Do not start this at 4 p.m. on a Friday, because if it runs long, if something happens, it's eating into your weekend, right? So plan it, schedule it for at least those 90 minutes, but maybe add a little bit of time in case you need that extra time. Then simply you pick your tests. You start easy, right? Figure out what you're going to do, figure out what you want to break, how you want to break it. Not too hard. Write down what you expect to happen when you do break things, right? So think of it as a scientific experiment. What's your hypothesis? If I take down the data store, what's my service going to do? What sort of alerting should I receive? You know? And your hypothesis does not have to be, and probably shouldn't be every single time, that your service survives, right? We'll talk about some of the tests that we run, but it's really not logical to assume that you can build services that if you cut off all their critical dependencies, if you drop the network, that they're just going to keep going, hunky-dory, everything's fine, right? So write down what you expect to happen. Also write down what your plan is. What's your fallback plan if everything goes wrong, right? If you have a cascading failure. Let's say you start off in staging and you're like, cool, I've got these tests, no problem. I don't expect things to fail, so you don't write up a plan, and suddenly you take down all of staging. Your entire organization is down, nobody can test code, no one can work. Well, that's a bad problem. So whatever you do, write down your plan B. What are you going to do if things go wrong? And then finally, most importantly, share the document. Not just to your team, not just to the two people playing, that other SRE that's with you, or if you're the SRE, not just to the engineer or the junior engineer. Send it as wide as you can, at least to your entire engineering organization, all of your developers, all of your ops engineers. But even consider more broadly, right? If you're starting to do game days in production, send it company-wide, right? Think about your account managers or your sales reps. If they're out there talking to a customer and the customer, your chaos engineering plan kind of fell apart and starts to impact latency on your production systems, and your customers start complaining, they're going to not complain to you, they're going to complain to their account reps or the salespeople, right? So it's good to share this information as broadly as possible because it may impact other people, and it's good for them to know. So that's the 30 minutes, right? Nice short planning, not too much involved. So what happens during? Well, when we actually run the game days, we do start off in staging, right? You want to start off in a safe environment. And then once it passes there, we'll promote that and we'll try it in production during off-peak hours. And then we'll move that to prime time. We'll run it in production in heavy times of actual customer traffic. So when we start the game day, when we start the actual playing, you want to announce that. And you want to announce that within your group chat tool, whatever you're using, HipChat, Slack, whatever sort of chat ops tool you're using, because it's a way to get things broadly, right? If I just come into the room and say, hey, everyone, I'm doing this, well, Bob might be out getting coffee. He has no idea that happened, right? So we want to announce it in a tool that everybody has access to and in a tool that records things, because we want to maintain our discussions there. Because if it's me and an SRE and we're teaming up and we take down a system and I'm trying to type up notes and things are going on, well, what did I say 5 minutes ago? I was talking about this thing that I observed and then you saw this other thing. If it's all in Slack, if it's all in HipChat or whatever you're using, now I have a complete dialogue of everything that was said. And when it comes to taking notes later, then I can just post a link and say, here's what we saw, here's what we were discussing, right? Keeps things nice and easy. We also want to monitor for outages, and we do this in two ways. Obviously, at Datadog, we're a monitoring company, so we have tons of dashboards. You want to keep whatever monitoring tool you've got open, be monitoring your systems. But also, we have an outage channel within Slack, right? So we want to keep aware of that, because if anyone declares an actual outage, that's a cue for us to stop what we're doing, right? We don't want to add our game day or our chaos into their actual real chaos while they're trying to debug our systems or bring systems back online. So you want to monitor for that. And then finally, you play, right? You break your systems, you run your tests, you take your notes, you explore your systems, see what they do. For the after, again, we want to keep this nice and short because this is the boring part. This is not the fun part of playing. But the great thing is, you've taken notes, you have that dialogue within Slack, so you just paste the link to that. You create cards and tickets. Whatever tracking system you're using, whether that's Jira or Trello, whatever you've got, you write those down. The things that you saw, like, oh yeah, when we broke this thing, our monitor didn't go off the way we thought it did. Or I got an alert, but it had useless information in it. So you just create the tickets right there, right? Make sure that those get done. You write your summary and the key lessons, and the summary is essentially your notes. Again, you don't have to spend a whole lot of time. You shouldn't spend a whole lot of time with this. Copy your notes in there, copy the link to Slack, write up some of the things that you observed, those key lessons, those key points that you want people to take away. And then you email that out, right? To all of engineering, at least, at a very minimum, maybe to your entire organization. Because again, the whole point about this is learning from these failures, so spreading that information as far as we can becomes beneficial. And finally, the most important part is you celebrate. At Datadog, we love to celebrate anything and everything. Any possibility to celebrate, we do, including game days, right? If the game day goes great and you're like, we expected that our system would be completely resilient, we hammered it with traffic, we essentially DDoSed ourselves, and it auto-scaled up and handled all of that perfectly. Or, our WAF actually blocked that because that's what we were expecting. Like, great, you won. You built a resilient system. Congrats, you celebrate that. But similarly, if I roll out my chaos experiment and there's a cascading failure and I take down all of staging and entire engineering department's mad at me because everyone has to stop work, well, I fix that, but then I celebrate, right? Because I just learned something that's really important about our systems. I learned where that critical fault was. And now we're on the road to fixing that, right? So you want to celebrate everything when you do these. So let's talk about the tests that we run. We have 5 different levels, or 6 because we number with 0. But the first is to terminate the service, right? If I turn off this service and I just restart it, does it actually restart? Does it restart without any human intervention, right? If I have to restart my server and then log in and enter some credentials because I'm not using, a secrets manager, well, that's a bad thing. If I restart my application and because I did that, because it was down, my router isn't actually sending traffic to that, well, great. If your service is up but not receiving traffic, that's a bad thing, right? So really simple, terminate your service. The other thing we do at this level is block access to one critical dependency. So whatever that is, if it's, you've got a build system and it needs to load libraries or other components, block that. What happens with your build system? If it's, a service that has a persistent data store, what happens if you block access to that data store? Again, it doesn't have to survive, right? If I have a user login service and I block access to that data store and people can't log in, well, that's not great, but at least that's what I should expect, right? And if that's what I expect and that's the way that the service operates, well, then that's a good thing. From there, we level up. We block access to all the dependencies. And again, we want to ensure that it acts the way we expect it to, not that it survives. If it survives, that's amazing. But we want to ensure that it expects the way we do. So we want to verify that errors are reported, right? That we have proper monitoring on that. That if we block all those dependencies, we should at least get some sort of alert. And that automated alert should go to my team. It should have links to my dashboards. It should have links back to some sort of documentation with a run book that says, if this happens, here's what you look at. Here's what you try to do to resolve that. The next level up is we terminate the entire host, right? So we take down that node or that VM, and we see if it fails over to another one. Hopefully it does. We verify that that traffic gets redirected to that new host, right? Because we don't want to have to manually do that. This also helps us guarantee that hosts are replicated across availability zones. and that similarly their data stores are replicated as well. Level 3 is that we degrade the environment. So we're starting to get a little more complex here, but we do things like slow down the network, start dropping packets, introduce jitter. We want to verify here that we can survive this, or that at least if that data is coming in and it's incomplete because we've missed packets, that our systems can now start to maybe retry those, or at least identify that it's gotten malformed information. We also want to verify that we have what I call LETs. So Google, a while back, their SRE team wrote the Google SRE handbook. It's published by O'Reilly. And they have this thing called the 4 golden signals, which it's a high, nice, lofty name. I never remember what it is, so I reorganized it and said LETs. LETs is a nice acronym for latency, errors, traffic, and saturation. Latency. Are we seeing increases in latency? Do we have proper monitoring for that? Errors. Are we monitoring what sort of errors we're receiving? What's the error rate? Traffic. Are we seeing more traffic or less traffic? And we want to monitor that in both ways, right? If I'm seeing more traffic, well, that could be good. It could mean that whatever we tried, users are actually engaging more, and so we're seeing higher traffic. Or it could be bad that something that we rolled out, something that we're testing is less than optimal, and now we're issuing more requests against the server. Similarly, saturation. Do we have enough resources, whether that's compute, I/O, network? The great thing about this, though, is once you pass this level, once you're able to survive a degraded environment, once you're sure that we have complete monitoring on that we've got those metrics, that we've traced this application, that we've got proper logs, this is the time when you can actually hand off to the SRE. So up until this point at Datadog, if you write a service, you write that service, you're responsible for it, which means that you're on call for it. You have to run what you write. But at this point, because we know we have full monitoring on this, we've tested that things react the way we think they should. We've got proper alerts that have runbooks that tell people, even if they don't know very much about the service, it tells them exactly what they should do in case of an incident. Well, that means it's ready to go to an SRE. So now that SRE can actually start to take over some of your on-call responsibilities, which this is a great level to get to, right? It means no more constant on-call. You have somebody to back you up so you can sleep better at night. Level 4 is where we spike the traffic. So we essentially try to DDoS our own services. What happens when I receive a ton of traffic? Do I have auto-scaling turned on? Is my service set up to run asynchronously? Can I pass those jobs off and queue them and then run them at a later time? And then level 5 is mass destruction, nuclear outage. What happens if we just nuke Google Cloud, right? Can I fail over to an on-prem? Can I fail over to another cloud provider? I do have to caveat with saying that at Datadog, we're multi-cloud, but not all of our services are at this level yet, right? This is the dream. This is where we're pushing towards. And actually, that Google announcement, Anthos, that's pretty cool, right? You can start to do multi-cloud, and they're making it easier. So I've talked about a lot of stuff. I know it's early, and I've seen that some of you are like starting to nod off. So who wants to run an experiment? Yeah. All right, so let's switch over and run an experiment. Right? I'm going to keep this nice and easy because it is early. But let's start off with that planning, right? This planning, it would be normally 30 minutes, but because we're in this session and I have 25 minutes left, we can't actually spend that amount of time. But scheduling it, congrats, we're doing it right now. I'm letting you know right now. We're going to choose a test. So I've got a WordPress site because I think everybody understands WordPress. It's a nice, simple, easy thing to do. Let's kill MySQL, right? What happens if WordPress has no data store? And let's try a few ways, right? So I've got it running in Kubernetes. So I'm going to say that the way we're going to kill this is we can kill the pod, right? We can kill the deployment. And then I actually was wondering last night, I've never actually done this, but what if I log into my pod and just like kill -9 the actual service, right? So what do we expect to happen? Shout it out. If you have a WordPress site and MySQL goes down, what do you think is going to happen? WordPress is going to get even slower. Nice. High latency on WordPress. Someone said 500 error. Anything else? What can we expect if I take WordPress, MySQL down? MySQL errors? All right. What about alerting? I should receive some sort of alerts, right? So, cool. Those are some good things. What are we going to do if things go horribly wrong? Well, we're going to walk away. It's early, so I'm probably not going to go to a bar and get a beer. But if things go horribly wrong, and for some reason this cascades and takes down the Google Cloud Network, then yeah, I'm definitely walking away. I may be running away. But maybe we can go get some coffee and hang out. So cool. That's it for planning. Nice and easy, right? And then I share this. So this is actually available online. I've got the URL, and that'll be in the slides later. Cool. So just to show you, I do have this WordPress site that's here. It looks like it's operating pretty good. And I'm going to switch over. I've got WordPress running in just Minikube on my computer here, because I didn't want to tempt the demo gods. But we can see that, yes, I still have some pods running, right? So we go back to our document, and I said, what are we going to do? Well, let's kill the pod, right? So if I do that, delete pod, and I'm going to take down my SQL here. Cool. Says it's deleted. I can come back here. I see an error, and then it's back. Cool. That's pretty much what we expected, right? Kubernetes is nice and fast at that. So if I just go back up there, we can see that, yes, it restarted. It was pulling up everything just fine here, right? It's still got my image, so my persistent volume claim worked. So things that we saw. We can just say that we killed the pod, and it respawned as expected. Cool. Super easy, right? So let's try, what if we delete that deployment? Cool. So now if I do that, we should see that my pod is terminating. It is. Come back here. We see that ugly error establishing database. So we'll make a note of that. WordPress is essentially non-responsive, right? Non-responsive with an error. And then I should get alerts. So let's see. Did I actually get an alert? Let's go to my monitors. I do have an alert here that MySQL was killed. I want to check in my email. If I refresh here, I did get an alert on my email. And it's got some information here, which might be hard for you to read in the back. It says MySQL was killed. If this was not intentional, please verify the Kubernetes deployment. Number one, check the Kubernetes dashboard. So I can click on that. Takes me to Datadog, loads up my dashboard here. Can take a look at this. I see that pods desired, pods available, 5. So those match, desired and ready. So overall, it looks like things are working quite nicely still on Kubernetes, which is what we'd expect. Then it says check out our team documentation, which I don't have any example documentation, but that's probably a good thing for us to do. And then it says to restart MySQL, ensure you have the latest YAML files, and then run this command. So let's verify that our instructions in our alert is actually what we expect. Right? So I reapply that. It looks like those are unchanged, and then it's got my deployment there, so it's recreated that. And if I get my pods, it's back up and running. So does this actually run here? Cool. WordPress is back, right? Exactly as we expect. So we killed that. We should say that we received alerts. it had some steps that worked, right? So we can fill this out a little bit more later, but we're just taking notes here. Anything that we didn't expect? No, not yet. So we had one more thing that we wanted to try, and that was up here. Let's log into the pod and kill -9 the service and see what happens. So I've got my pod that's back up and running. That bin bash. Cool. Oh, that's fun. Sorry? Oh, yeah. No. Oh. So this is a fun thing. Good to know that we are running maybe, I think this is Alpine, which means that they removed that. Yeah. All right. So I'm not going to dive down that rabbit hole, but that's a good thing. And that's actually something that we can note here, right? Like, we're actually running, we're running in a minimal container that doesn't have PS, right? The cool thing about that, though, is we probably, in this case, if we're running this in production, we want some other tools. So things that we should change or fix now, as we're taking notes, is we should set up some dev tools so we can PS on containers, right? Cool. We just learned something, and actually, like, I hadn't planned this. I was just randomly thinking what would happen if I did that this morning. Cool. So experiment has been run, right? Again, super easy. We learned some stuff about what we're running. And then we've got the lessons learned. So again, this is the super short part. It should just be 10 minutes. We make Jira tickets. So this is our Jira ticket, right? So we go into Jira, we make that. We write a summary of things we saw, things we didn't expect, which essentially is copy-pasting this, right? And then we share this. So we're going to email this out, and then finally we celebrate, right? So yeah, we ran an experiment. It worked. We learned some stuff. Cool. So I'm going to update this gist, and it's now saved, so you guys have access to it. So if we go back to the slides, just to review, if I had to boil this down to 3 points, right? There's all this advice on how you should run things, but at the end of the day, it comes down to this. It's sharing. Share what you do. When you're planning things out, you're sharing that as broadly in your organization as you can. When you're actually running things, you're sharing that, right? You're letting people know that you're running, and then finally, you're sharing what you learned across your organizations. Number 2, to sum this up, is to plan, right? Simply just come up with those experiments, plan those out, plan what's going to happen if things go horribly wrong, and then finally have fun, right? We're learning about things. We just learned that we didn't have PS. We don't have the proper admin tools within our containers, so we need to plan for that, you know? Have fun, celebrate. We just learned that, so, you know, I wish I could take you all out and like buy you a celebratory beer, but it's also super early, so you can celebrate in your own way. A few other resources, though. Again, I advise you to keep things simple, right? Systemctl, kill. Kill-9 your services. You don't need super complex, fancy tools for this. Keep things simple when you're testing them. A few other things that we do use, though, as we start to level up, I mentioned that you want to simulate bad network conditions. So that's what Comcast is there for. It's a nice tool. It is hilarious. I shouldn't say disparaging things about Comcast, but I think we've all experienced their ISP services. Vegeta is a nice one. If you've ever used Apache Bench, which comes with the Apache web server, Apache Bench essentially allows you to simulate traffic. Vegeta is like Apache Bench on steroids. So it's written in Go. You can essentially DDoS yourself, but it's also got some great tools where when you do that, it'll start saving up some data, and you can pipe that back into Vegeta, and it'll generate drafts for you, so you can actually have nice summaries of what you've been doing. A few other things, Gremlin. Gremlin, I know they are sponsoring downstairs, but Gremlin is chaos as a service. They rolled out a free service, which allows you to essentially do node killing or service killing, and then also CPU tests as well. So those are available freely. They integrate with Datadog, so it's really cool. If you do use Datadog, you can launch those directly from your dashboards. It lets you know when the test was running, allows you to monitor your metrics through the course of the test. And then finally, Chaos Toolkit, another great resource. They have a bunch of information on how to run chaos experiments, a bunch of tools that you can actually use as well. So with that said, open to questions. So if you think of anything afterward, you leave here and you're like, oh, I wish I knew more about this, feel free to email me, or that's my Twitter handle. You can tweet at me, and I'll answer those questions as well. And then these slides are available online, and the documents of the experiment that we just ran, those are available in a gist as well.